So what is the average rate of a function? Now let's say we have a curve on a Cartesian plane. Let's actually say it is a graph, but it is a curve on a Cartesian plane. We know this is y-axis and this is the x-axis. And let's say we have a curve. Let's say it is going like that. Just now, let's say along the x-axis we have a point given as A, and we also have a point, let's say, given as B. And let's say the function, let's say the curve is of a function, let's say f of x is equal to y. Let's say this is the function corresponding to the curve. Just now, what is a point along the curve corresponding to x being given as A, of which this is the point, and also the point corresponding to a B along the curve, also have that one as this. So now, what is the y value corresponding to x being given as A at that point? So now you see that, or have it as in this case. So have it as f of A. And also for this point, also have it as, should be given as f of B. So have that and as that. So now let's think of connecting the 2 points with a straight line. Let's say that's the case. So the straight line is said to be a second line. So it's said to be a second line. So it is said to be a second line. So that is. So the gradient of that line is what we call the average rate of a function. So the gradient of actually this line is what we call the average rate of a function. Now, from the definition of the gradient, so the gradient is given as a change in y divided by the change in x, which is given as y squared should be y2 minus y1 over x2 minus x1. The same principle also be applied in this case. So now only that we'll have to present the symbol for the rate of change instead of having the symbol for gradient, but having the rate of change, it is the same as the gradient. So now what is the rate of change? Rate of change is given as a delta f divided by a delta x. So that's the actual rate of change. Now if the function is in form of, let's say it is a function of t, it means we'll have delta f over delta t. So that is. So what is actually a delta f? So which means we'll have fb minus fa, and that divide by what is delta x? We have b minus a. Now this is the formula for the average rate of change of a function. So take note of that. So this is f of b minus f of a, which is given as y2 minus y1 divided by x2 minus x1. So that's the formula for the average rate of change of a function. Now let's say we have the following problems. Let's say we have a function. Let's say we have a function. Let's say we have a function f of x given as x squared. Now find the average rate of change of a function on the following closed intervals. Let's say we have, let's say 2, 1. Now it should be that. Should be now 1, 2. So what is the average rate of change of a function within this interval? So we know that the formula for the average rate of change is given as delta F divided by a delta X, which is given as FB, F of B minus F of A divided by a B minus A. So what is the A? We have it as 1. What is the B? We have it as 2. So what is F of, should be F of A, which is F of 1. So now we'll have it as a 1. What is F of 2? So now have it as a 4. So which means we have to substitute into this in order to have the average rate of change of a function. Now we can have it as being given as should be 4 minus 1 divided by 2 minus 1. That will be given as 3. So that's the average rate of change of a function within that interval, which is 1 to 2. Now what if we have this case now? Let's say we have the interval, let's say -2, 0. We should have the average rate of change of a function within this interval. So we have A being given as -2, and this actually B is given as 0. And the formula for the average rate of change is given as delta F divided by delta X, which is equal to F of B minus F of A divided by B minus A. So try to have that on your own. And also see how you should have to go over this one. Let's say we have a function F of X is equal to the square root of X. So now what is the average rate of a function within the interval 4, 9, if this is the case? So now we have A being given as 4 and we have B being given as 9. So what is the F of A, which is F of 4? So have it as the square root of 4, which is given as 2. So what is the F of 9, which is the square root of 9? We have it as a 3. Let's now try to proceed out to have the average rate of change within that interval at your own time. And also let's think of having this case as well. Let's say we have a function F of X, that which is given as x cubed minus x, and that is try to have the average rate of change within the interval 0 to 2, that for the function. So now sometimes you can also have to use another formula to have the average rate of change of a function. We also have another formula that will help us to have the average rate of change of a function. So that is said to be, in this case, the average rate of change given as a delta F over delta X can also be given as F of X minus F of A divided by X minus A. This is also the formula for the average rate of change of a function. Now let's say we have this problem. Let's say have F of, let's say X is given as, let's say, X squared. So what is now F of X minus F of 5 divided by, that should be X minus 5. So this is the same as having the average rate of change in that case. So F of X is the same function. But what is F of 5? So F of 5, it is given as a 5 to the power 2, which is given as 25. So now, which means we'll have x squared minus 25 divided by x minus 25. So in this case, we'll have it as x plus 5. Now, since we have the different two squares here, so have x minus 5 divided by x minus 5. So then that will have it as x plus 5. So that is the value. And what if we have this case? Let's see, we have f of x being given as x squared and plus 3x. So now find should be f of x minus should be f of a divided by x minus a of this function. So now principle remains the same. What is the f of a? So have it as a squared minus 3a. Then it means we'll have it as x squared plus 3x, much as f of x is the same function, and the minus, so have it as a squared minus 3a. And of which you have it as divided by x minus a. Now we'll have this case now. So now we'll have it as x squared plus 3x and then minus a squared and then plus 3a, which is divided by x minus a. So now let's think of having x squared and minus a squared together, because those are different to 2 squares. So now have x squared minus a squared and plus 3x and plus 3a and divided by x minus a. So in that case we'll have, now we'll have to factorize this. Now since those are different 2 squares, we'll have it as x minus a times x plus a and the plus. How about those 2 guys? So have them, let me just have to pair up them. So now which means we'll have 3, so x plus a. So now as you can see, we have the common actually a factor in this, that is x plus a. We'll have to factor it out. So now have it as x plus a and the overall x minus a, so it should be that x minus a. So now for this problem somewhere I've messed it out. Let me just have to go back to, I've messed it out somewhere. So sorry, but you understand. By the way, we have a function given as f of x, so it should be f of x and which is equal to, now have x squared and plus 3x. That is the function. So now find f of x minus should be f of a over x minus a. So now which means I'll have x squared plus 3x, that which is minus, now what is f of a? We have it as a squared minus should be a 3a. So that's why I missed it out. I forgot to have this one as a negative as well. That should be in this case. So have should be a squared plus 3a divided by now x minus a. So I have to distribute negative, or if I'll have it as, let me just have to So now which means we'll have it as x squared and that plus 3x minus a squared and the minus 3a. So now it is fine. Divided by x minus a, and of which you have to bring x squared and a squared together. So have x squared minus a squared. You have that in the a plus 3x and the minus 3a. We'll have them as that. And the divide by x minus a. So I have to factorize this one and also this one as well. So which means we'll have it as x minus a times x plus a, which is plus 3, and our x minus a divided by should be x minus a. So we'll have that and as that. And we're going to factor out x minus a because here we have it as that, and also here we have that and as that. So x minus a, so have x plus a and that plus 3, or over like that. So just have that one divided by x minus a, of which this one will cancel. Now have x plus a plus 3. So that is the answer. And what about if we have this case? Let's say we have a function f of x, and which is equal to 4x squared. Now find f of x minus f of negative 2, and divided by x minus 2. So it should be x plus 2. So what is that one? So what is the f of negative 2? So now have it as 4 times negative 2 to the power 2. That will be given as 16. So now which means we'll have f of x, which is 4x squared, and minus 16, which is divided by x plus 2. So that one. So we'll have to factor out actually 4. We'll have 4 x squared minus 4, which is divided by x plus 2. So also have to factor out these because these are different two squares. So have it as a 4 times x plus 2 times x minus 2 divided by x plus 2. And have to cancel those. We'll have it as 4 x minus 2. So that's the solution. And we also have another form of a formula that can help us to have the average rate of change of a function. And what's that? Now we have it as also, it is also part of the quotient as well, the way we have done it before. So you should also have to look over that as well. Let's say we have a function f of x. Let's say this is f of x is equal to x squared. So now find the value of, let's say, f of 2 plus h minus should be f of 2 divided by, let's say, h. So this is also the form you can have to use in this case. So what is the f of 2 plus h? So in this case we'll have it as a 2 plus h to the power 2. So what is that one? So now have it as 4 plus 2h plus h square upon expanding that one. That is, and what is f of 2? So have it as a 4. Then I'll have to substitute into the formula, and that will give us now, we'll have it as 4 plus 2h plus h squared, and minus 4x. Should be minus 4. And divide by h. And of which this 4 and this 4 cancel. And we'll have, and this knowledge will be very important when we're looking about the calculus. When you'll be actually looking about calculus, this knowledge will also be very important in the basically differentiation part. So you also learn about the differentiation in calculus. That would be very important as well. So now, which means we'll have it as 2h and plus h squared over h. So I'll have to factor out h on the numerator. I'll have it as now h 2 plus h over h. That will be given as 2 plus h. So that's the solution. Now what if we have this case now? Now let's say we should have to evaluate what is f of x plus h, and the minus f of x divided by it should be h, and therefore that function. So what is the f of x plus h first? So have it as x plus h to the power 2, and this is the same as x squared plus 2xh plus h squared. That is upon expanding that one. Now what is the f of x? We have it as the same function, which is the x squared. So now I have to create some space here. So now that will be given as x squared plus 2xh and plus h squared, and the minus should be x squared, and that divided by h. So have that as that will be given as 2xh and plus h squared divided by h. So I have to factor out h, then cancel this one. You'll be able to have the answer there. So that's how we should have to understand about the further analysis of the rate of change. Now let's say we have, in this case, let's say we have f of x, and that is given as, let's say, x squared should be minus 2x plus 4. Let's now find f of x plus h minus f of x and over h. So what's that one? So which means what is f of x plus h? So have it as x squared and plus 2xh plus h squared, and the f of x is the same function, which is given as x squared. So try to have that out on your own, but you should have to have that actually a solution. And let's say we have f of x, which is given as negative 3 over x squared. And find the value of the following. So let's say f of x and minus f of a of x minus a for the same function, and also should be f of x plus h minus f of a of h should be f of x of h, and therefore the same function. So try to have that out. So that's how the rate of change should have to understand about